This man is the man in the black shirt who goes out and makes sure that everybody knows how to rub DevOps on it. This is a man who likes to attack the stage. He is a very good close friend of mine. I love him dearly. Please give Donovan a warm welcome to VS Live, and let's hear about DevOps.
Thank you. Thanks so much, and good morning, everyone. We're going to try that again. Good morning, everyone. Good morning. Perfect. Come on, you have no idea how hard it's been for me to get here. This is my third keynote in 3 days, and I've been in different states giving those things. So I need you to give me some energy because I am on my last leg. The adrenaline's starting to pump. I feel the hair on my arm starting to stand up. So we're going to have some fun. As he just said, I'm a principal DevOps manager. Having DevOps in my title, I am constantly asked, what is DevOps? All right? What was interesting is I was actually asked that question at Microsoft. And what I wrote down as the answer ended up becoming the definition that is on all of our web pages. So very proud of it. It took me 30 days to write the sentence I'm going to show you. 30 days. Because I didn't just go off and find someone else's definition and tweak it. I literally thought about my own career. How many of you remember a little company called Compact Computers? Anyone? Yeah. Oh, wow. That's a lot of old people here today. Yeah, me too. That's where I started. Exactly. But that's where I started my career back in 96, I believe it was. I was writing Windows software for Compact, right? So I've been around a long time, and I kind of thought about my career and what is DevOps really trying to do that we weren't doing back then? Why is DevOps even a word? And I labored over it, and I wrote down this sentence. And then recently, I found this video that I was like, man, I wish I had seen this video when I was laboring over this for 30 days, because this, in my mind, just crystallizes what your company can look like before and after it implements DevOps. So what I want to do is I want to share that video with you right now, and then we'll talk about it here in just a second.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. Tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
So when I saw that video, I thought, that's it. Like, that's what we're supposed to be trying to do. I'm extremely active on Twitter. It is the #1 way to get a hold of me. So I tweeted that video, and I said, DevOps before and after. Generally, people got it, right? But 2 people said there was absolutely no value whatsoever in the second pit stop. None. And I'm completely perplexed. I'm like, how do they not see how much value was in the second one? One person says they didn't even refuel the car. They didn't refuel it, so they didn't add any value. The other one said there's so many more people in the second pit stop, they didn't really solve any problems. At this point, I'm clearly having like a physical reaction because my wife walks into my office and says, what's wrong with you? So I'm like mumbling to myself, they just don't get it. How do they not get it? She's like, what are you talking about? I said, they don't understand how this is a perfect analogy for DevOps. I said, I should write a blog post. She's like, yeah, you should write a blog post. So I did. There's a huge blog post that explains why this is a perfect analogy for what your company can look like. But what I want to do is first address these 2 people with you right now. Now, I blurred their faces because I didn't want to shame them, but this tweet is still live, and you can go find it. And you can see exactly who these people were, okay? So let's talk about the increase in the number of people. I just talked about the fact that I used to work at Compact Computers. I worked back there when, as an engineer, I, Donovan Brown, would finish writing software. I would go into the production server room. I would pull out a tray, type in my credentials, and that damn thing would log in and say, welcome, Donovan Brown. Try that today. It's impossible, right? You don't even know where the production servers are. You damn sure don't have the passwords to those servers. And what I would do is I would log into the server, and I literally would be taking a hammer and beating this poor server to death, changing the registry settings, deleting files I didn't need anymore, adding my own files. And I didn't give a crap about what else was on the server as long as my software ran when I was done. I was literally swinging a hammer at it. And you had to be really quick back then, because if I ran out of the room fast enough before the IT pro saw me, it was their problem after that, right? So you had to be quick back in the 90s, man. Beat up the server, run out as fast as you possibly can. But it was just me and the machine. Today, there's ops involved, devs involved, QA, auditing, you name it, program managers. There are literally more people involved in deploying software today than ever before. So if you just look at it as there's more people, I'm like, yeah, there's more people today than there used to be. But what was interesting to me is when I saw this, I didn't see them as actually people. I saw them as automation. I saw them as the microservices. I saw them as the best practices that we apply every single day. I saw one of them as continuous integration, the other as continuous delivery. One is continuous monitoring, and it's actually there. These two gentlemen never move. They never move. They are looking at a 3-second pit stop, trying to figure out how they can make it a 2.5-second pit stop next time. They are monitoring what they're doing, and they're going to learn from it. It's exactly what you should be doing in your DevOps pipeline. How many of you are on your DevOps transformation right now? Right, so the first time you built a DevOps pipeline, I bet it didn't work. So what was your first idea? How do I roll this back if something bad happens, right? You constantly think about rollback. Check this out. This gentleman has a jack. At some point, that jack must have failed because that guy has a jack too. That's exactly what happened to us the first time we tried to do DevOps. It didn't work. We're like, crap, we got to figure out how to roll back. That's exactly what happened there as well. Microservices, continuous integration, continuous delivery. I take the tire off, you put the tire on. And what we do is we string together these processes so that we can move faster than we ever have before. So if you look at them as people, it works. If you look at them as automation, it also works. Now let's talk about the gentleman who said, you didn't even put fuel in the car, so you definitely did not add value. You're completely missing the point if you agree with that statement. The point that they did not have to fuel the car is the magic part. It's not that they didn't, it's that they did not have to. Because trust me, if that car needed fuel in it to finish the race, they would have put fuel in that car. But what they did is they completely eliminated the bottleneck by shifting left, technology, innovation, to make that car go further on less. Think about that, right? The point isn't that they didn't put fuel in there. And let's look at this again real quick. If you watch this again, is fueling the car the most painful part of this? No. Because even if we refuel the car at the same rate they did back then, today, we'd be done in half the time. This is where you go focus on the thing that hurts most first. So in my mind, the way that this played out was they're like, man, if we could change those tires faster, we'd be done in half the time. So they go and they figure out how to change the tires. Instead of 67 seconds, maybe they get it down to 10 seconds, right? Now all of a sudden, there's this poor guy with this gas on his shoulder still sitting there for another 20 seconds. They're like, okay, you're the bottleneck now. And that's exactly what you should do in your DevOps pipeline. Find the thing that hurts the most. Don't rip and replace everything. Fix that one thing and let something else identify itself as the bottleneck. Then what do? You can go back and say, okay, how do we get rid of the gas problem? We can't make physics go faster. We can't pump gas in there any faster. So what if we completely eliminate the need to fuel the car at all? Let's make the tires more efficient. Let's make the engine more efficient. Let's figure out ways that we simply can eliminate that bottleneck. Then what happens? You realize that, holy crap, 10 seconds to change tires is still too long. Because that's the bottleneck again. It's okay when you're building your DevOps pipeline to go back and revisit areas you've already visited in the past. If they become the bottleneck again, that's okay. That just means you're doing so much better in other areas that this is now the problem again. And hopefully by then, technology is caught up, best practices have caught up, and you can go back and revisit that. So you go from this to something that looks like this. And again, it takes monitoring, it takes learning, it takes DevOps best practices. And if you're not doing this and your competition is, you're the people being lapped. Because you remember the first video when it played, you could hear those cars just lapping. Every couple seconds, there's another car just passing you while you're in the pits. That's your company when you do not realize that DevOps is the way that you do this. The time to debate, should we implement DevOps or should we not? It's over. You either implement DevOps or you lose. It is that simple, right? You got to get your people on board. So after laboring over this for 30 days and seeing this video, this is what I came up with. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word is value. It is not about delivering software. It is not about getting the top item on your product backlog off. It is about delivering value. What's really important about that is that you can deliver value without changing a single line of your software. We just had Cyber Monday and Black Friday. Those websites were getting beat up really, really bad. Did I have to go change my software to be able to sustain more simultaneous users, to keep my response times down? No. I could have my operations teams go up and scale out and scale up my infrastructure and deliver value instantly. So stop thinking about it as software. And if you think about the way that ops teams and developers are incentivized, thinking about it as software is a really bad thing. Ops teams, they get big bonuses when what? The lights stay on all year long, right? What's the best way to keep a server stable? Don't change it, right? I'm a developer. I get the big bonus when I add a lot of features. What do I have to do to add features? I got to go change that server. So for you to get big bonus as an IT pro, you have to stop me from doing my job. And for me to be really good at my job, I'm going to give your job's going to be hell, right? As I'm in there destroying this particular server. But what if we were both incentivized the same way? What if the only way the IT pro got a big bonus and the dev got a big bonus is if we delivered value to our customer? You align our goals, we're automatically going to work together. But right now, we're incentivized differently. The way we're measured, the way we're rewarded, they don't align up. You got to get your people on the exact same page, and that's focusing on value and not software. The process, we all get this. How many of you think you're agile? A couple of you. Oh, so some of you think you know you're agile? Is that why you didn't raise your hand? No, you don't. Right? I got all the process consultants in here that know better than that, right? You think you're agile, that's great. So we know agile, Kanban, Scrum, we know the processes. And the products, there's tons of them. There's some from Microsoft, there's some from our competitors, there's lots of products. But the problem is the people. You're sitting here right now, and I hope you leave here motivated and excited about DevOps and what it can do for you at your company, but you're going to go back to a company where your peers were not sitting in here. And your peers are going to want to keep doing it the same way that they've always been doing it because it's comfortable. That's how they've been making their living. Why would I change it? Especially if you're at a company that's really successful. That's the hardest one. Because if they're number one in their industry doing it the old way, why the hell would they change? We're winning, right? But what they don't realize is that if you keep doing it this way, there's some startup that's going to come out there and completely wreck your world. Ask Walmart about Jet.com if you don't believe me, right? Within 12 months, Jet.com was worth $3.3 billion. And luckily, Walmart had a checkbook where they could write a check for that and buy that competition. If you can't afford to buy all your competition, you better be able to out-innovate them, right? So you got to be quick on this. Make sure your people get it so that we can do this. This is our North Star at Microsoft. This is what all of our teams are driving towards, continuously delivering value to our end users. And we had to do this on what is now called the Azure DevOps team. I might call it VSTS, same product, right? Old habits die hard. Some of you still call it VSO. I'm not mad at you, all right? Some of you still call it TFS, whatever. It's been so many different names. Just use it. I don't care what you call it, honestly. So how did we do that, though? How did we take what was a boxed product and ship it as a service? One of the main catalysts was this gentleman here. Since he's joined, Microsoft has completely done an about-face. We're the #1 contributor to open source on the planet, which the older people, their heads hurt now that I just said that. Right? Because we all know when we thought open source was a cancer, Linux was a cancer, it was the worst thing in the world, we're never going to support it, and now we're the #1 contributors in the world. Right? Because this person came in and said, we're going to change how we think, we're going to change our culture, we're going to change our anatomy. I remember once I got to hear him speak at an internal conference called Tech Ready. And it's a conference inside of Microsoft where half of us get together and we learn what's coming up new. And he was going to keynote, and I was so excited because it was the first time I was going to be able to hear him speak. And I was sitting front row, dead center, just beaming that he was going to come speak to us. At that time, I was a seller at Microsoft. I was brought in to actually sell Team Foundation Server, and at that time, VSO. And when I'm sitting there talking to customers, I always had this sinking suspicion that they were going to ask me the question I did not want them to ask me. Does Microsoft use TFS? Because back then, the answer was no. Luckily, they all thought they did, and they never asked me, so I never had to lie, right? But it's a dirty little secret that we were not using TFS 2005, right? But we were asking you to use it until this man showed up. It was like he spoke directly to me. He's sitting on stage. He says, here at Microsoft, we have to stop living this fake life where we would write software for others that we would not use ourselves. I was like, man, make that true. because I can't wait to be able to tell our customers we actually use this product. Well, I'm happy to tell you, Azure DevOps is built, designed, tracked with Azure DevOps. It's this weird inception thing. Windows is using it. Office is using it. The entire organization is now going to use one engineering system. So I can now proudly say we all use this thing, right? And that's why it got so good. When you have to dog food your own product, it gets good really, really quickly, right? It's amazing how that works. Who remembers this when you used to get these cool little binders? Does anyone still have the white binder? I have the white binder. I was going through them last night. Well, actually not last night, last week, because I was in Vegas last night, looking for Visual C++ 6. You guys remember that one? Yeah, you can't find it online anymore. You can't download it. So here I am going through binder after binder trying to find this freaking disk to do some old code. But what's cool is that we stopped doing that, and we now ship it every 3 weeks online. How the hell did we do that? That's what we're going to talk about right now. TFS 2005. Funny thing about TFS 2005, it should have been called TFS 2006, because that's when it shipped, right? We were waterfall back then. We coded for 18 months, and we had done all the cool Gantt charts and worked our way back, and we were going to ship in 2005. Until we realized that we needed another 18 months worth of testing just to make it usable for you, right? Welcome February 2006, and then we ship it. We're like, man, that was a rough 3 years, but I bet you can do better now. We learned a lot. So let's just go away for 3 years, put our heads in the sand, and pop back up and say, hey, 2008 is going to be better. It wasn't better, right? What ended up happening is people like Jira started taking over the world when it came to work item tracking. Jenkins started taking over the world when it came to CI. And our product had a reputation of only working for .NET on Windows. Right? So they're like, okay, 3 years, that's too long to be away. If we're only gone for 2 years, though, that's the sweet spot. We'll get it right. We'll look in our crystal ball. 2 years from now, we're going to come back, and it's going to be perfect. Was 2010 perfect? No. It was very, very rough. But we were like, okay, we learned. 2 years is too long. But 1 year, yeah. Our industry moves so slow that if we were gone just for 1 year, it'll be okay. No. Our industry moves so fast that you have to be evaluating everything that you do. What is it called? Inspect and adapt, right? You need to inspect as often as you can and adapt your process. So we realized that that was way too long, and now we ship every 3 months on-prem. So the product that you can install yourself, that is installed, it's updated every 3 months. And it's installed from a code base that is also run online every 3 weeks. We went from shipping every 3 years to shipping every 3 weeks like clockwork. And how did we do that? We changed our people, we changed our process, and we changed our products, right? So let's talk about that real quick. The products that I'm talking about is called Azure DevOps. It is everything that you need to turn an idea into a working piece of software, but this is not a sales talk, so I'm going to go ahead and just switch over that. But I wanted you to know what is it that we're talking about. Like, what is the product? When I say we, by the way, I'm going to go ahead and correct this real quick. I'm going to say we a lot. I do not mean Microsoft all up. I mean this team right here. Right? Because not all teams run in 3-week sprints. Not all teams are doing DevOps the exact same way that we are. We're all on our own DevOps transformation just like you are. So Windows lags behind what we're doing in Azure DevOps. Bing is well ahead of us. So there's different organizations inside Microsoft all on this exact same transformation, but at different places. So just make sure that when I say we, you don't run out here and say Windows is shipping every 3 weeks, right? But we are in the Azure DevOps team. We are made up of 4 locations primarily: San Francisco, Raleigh, North Carolina, Redmond, and then Hyderabad, India. It's about 45 feature teams. So 45 teams of about 10 to 12 people work on this product and ship it every single day. We are checking into master every single day, 850 people. And we'll talk about how we're able to do that. We don't have any long living branches. We don't have any merge bombs. We are constantly merging back into master. We do about 600 pull requests a day, and every one of those pull requests runs over 80,000 unit tests. That's how we keep the quality up. And it also shows you that the product that we're working on actually scales really, really well. What does our team structure look like? Historically, it looked like this. We had program managers, we had developers, and then we had testers. And we realized that the quality of our product wasn't really good because the developers, first of all, weren't even using the product. They would get it code complete, and they would throw this thing over the fence to the QA team. They'd go off and have a pizza party because they hit a milestone. And the QA team is out there just finding bug after bug after bug, calculating all this technical debt. And then when we come back from the pizza party, we just get rained on by all this technical debt that we now have to go back in and do a bug bash and ship whatever it is we're going to ship by the date we promised to ship it. Bad way of doing design. And what we decided was we need to actually merge our testing and our developers into an engineering practice. You are responsible for the quality from day one. Because if you're doing it the old way, you're basically bolting on quality to an existing product. But if you do it this way, you are designing the quality into the product because you're writing unit tests ahead of time. You're thinking about the best practices and the way that you're going to get high levels of code coverage while you're developing the feature, not after it's already been shipped, and now you're trying to go ahead and bolt quality on after, right? You actually write much cleaner code using test-driven development than you do if you don't. It's not an easy discipline. Don't even kid yourself. It's not easy, but the end results are drastically better. And we also had to get our ops team to be a contributor, an actual first-class citizen in our org chart. So what we do is we take these people, and we take about 10 to 12 of them, and we make what we call a feature team. It's basically just a scrum team. The program manager is your product owner. They own the product backlog. The engineers are the people who own how you're going to turn this into a working piece of software and the quality. And then our operations teams make sure that everything works the way it does. And then we have a constant feedback between our feature teams and our customers. You can use user voice. You can hit us up on Twitter. You can actually get our personal emails, our business emails, and email us all your questions and concerns because we don't want our customers thinking that they cannot reach us inside of Microsoft. Our teams sit physically together. If we have any Microsoft MVPs, that is building 18. So the MVPs get invited to Microsoft several times a year. You can actually go find this exact room. Those people in there won't be the same anymore because we rotate them around so everyone's not stuck in the exact same room. But that is one feature team. Everyone in that room works on the exact same feature. If I need to talk to someone, I just swivel my chair. There's no finding them on Slack. There's no trying to set up a Skype meeting. There's no worry about, can you hear me? Is my mic on? Am I muted? None of that. The person you need to talk to is right there in that room. If you need to have a more spirited debate because you disagree on an API, outside of it are two what we call focus rooms that have doors on them so that you can go in there and have a more spirited debate whiteboard session. We do have conferencing software in there because I showed you we have 4 locations where our teams exist. And if you need to talk to a team in Hyderabad, India, we have all the conferencing software you need to talk to that team. But the team members you need to talk to are in this room. What I really like about this is that each one of these rooms had their own culture. Right? What I mean by that is that this room, as you can see, there's gentlemen that had the headphones on. Sometimes rooms will let you eat at your desk. Some rooms won't let you eat at your desk. This is one of the few rooms we could actually take a picture of and show it publicly because they're not all this nice and clean. Matter of fact, the room that I was in, which is a really cool room, is that the first day I go in there, I'm walking around and I'm stepping on something and I'm looking down what is this stuff I'm stepping on? And then I reach down and I pick it up and it's a Nerf bullet. You guys ever seen those long Nerf bullets, right? So I was like, why is there a Nerf bullet? And then it's like that moment in the movie where it focuses back and you look around and you realize everyone has guns in this room, except you. And then what happened is whenever they got stressful or they just needed to blow off steam, someone would just start shooting this Nerf gun and everyone, it's like war games in there. And you'd want to have a gun because if you don't have the gun, all the bullets are coming at you, right? So I obviously had to go buy a gun and get ready to be a part of this team, which is really cool because, again, it had its own culture. But if you don't like that room, what's cool is you get to choose other rooms every 18 months. So what you can do is we can do this thing called a yellow sticky exercise. Of the 45 teams, the leads get up and say, this is why you want to work on Git for the next 18 months. This is why you want to work on work item tracking. And what the engineers do is they actually get to go and put a yellow sticky on the team that they want to go work on. This is very unique to the actual Azure DevOps team. HR is not involved. You don't actually get a new manager, but you do work on a different team. So it's really easy for the teams to move around. About 80% of the people go back to the team that they're already on because they already know the culture or they've already bought the gun, right? So you don't want to waste that money, so you go back to the team that you're on. But for the 20% that actually move around, it's fantastic, right? Because we get that cross-platform, we get that crossing of experiences and just disciplines all throughout our teams, which is fantastic. But if you decide you want to go work on a team that's in Hyderabad, India, you're moving your ass to Hyderabad, India, right? That's the catch. The teams have to sit together because it just allows us with our collaboration way too high. Sprint length. If you're in Agile, you should have a sprint length. It should be relatively consistent. You should only change it during a sprint review when you decide, retrospective, when you decide that sprint was either too long or too short. So how did we get to 3 weeks on the Azure DevOps team? I wasn't there when we actually came up with the 3-week sprint. But when you do that, there's certain things that you ask. There's certain criteria that you go through. Like, should it be 2 weeks? Should it be 3 weeks? Should it be 4 weeks? Should it even be 1 week, which I've done before. I was working at a company that traded stocks. You can't make a bet 4 weeks in advance on the stock market, right? Just look at the stock market every day. I mean, one day I'm happy, the next day I'm crying. Like literally crying because of what happened to my portfolio. And then the next day I'm all happy again, right? So you have to be able to adapt to that and make changes. So I've actually worked on teams that had a 1 week sprint because they were working in the stock market. I've also had teams that had a 4-week sprint because they were working in the medical industry, and our product owners and our stakeholders were physicians. And we couldn't get them to come to a sprint review any more frequently than every 4 weeks. So moving any faster than that was just a waste of time. So how do we get to 3 weeks? I asked Aaron Bjork, who was there when this happened. He said, we call it the Goldilocks syndrome. Like, I don't understand the Goldilocks syndrome. I was like, yeah, well, we tried 2 weeks, and it felt too small. We tried 4 weeks, and it felt too big. Then we got to 3 weeks, it felt just right? Because if you do Scrum, there's a lot of administrativity there, right? There's a lot of ceremony there. There's daily stand-ups, there's sprint reviews, there's planning meetings, there's retrospectives. And in 2 weeks, it feels like you're in more meetings than you are developing, right? And in 4 weeks, we all strain our brains to try to make it fit into a calendar month, and it never fits, right? It never starts on the first day of the month and ends on the last day of the month. So 3 weeks breaks us from all that, and our estimating is really, really good. Estimating what I can do 4 weeks from now is hard. 3 weeks is a little bit better, right? So that's how we ended up with 3 weeks. So let's drill in on this. Our sprints look pretty much like this. The first 2 days are just crystallizing our sprint backlog, making sure that all our estimates are great. We send out an email that communicates exactly what we want it to do. And then 3 weeks from now, we're done. And this dark area here is our deployment. Our deployment is completely automated, right? We do have people who are responsible. They're called a shield team. They're responsible for the deployment, but there are no no human intervention trying to copy bits around. They're just there unless we have a live site incident, we have a hot fix bug that has to go out. That shield team is protecting the rest of the engineers so that they can focus on adding new features, and they focus on making sure that the code actually gets deployed successfully. It takes about 10 days to get deployed to all of the different rings that we have inside of the Azure DevOps. And then luckily that SWAT team or that shield team rotates every release, right? So it's not the same person always doing that. So what we do is we send out this email that says, this is what we finished in the last sprint, and this is what we intend to do in the next sprint. And in what we finished, there's actually a video, 3 to 5 minute video of the program manager actually showing you the feature that they just added. So imagine that you're virtually sitting in everyone's sprint review, right? Because that's what you're supposed to do in a sprint review is show me what value you added to the product. But since there's 45 teams and numerous time zones, I could never do that physically myself. But having these emails come in, I can now watch all 45 of these, make sure I know what all the teams are working on, and then see what they're planning to do, which is really important when I depend on another team that's in another time zone. I can read that email and say, hey, man, we're planning to deliver something that you should be working on right now that I don't see in your plan. So let's go ahead and have a quick conversation on how do I get this prioritized correctly so that we can deliver when we need to deliver. It's crazy that email works so well for us, but it's really powerful. And the emails look just like this. The top portion is what we got done previously, and there's a video that I can click on to watch it. And then the second half is this is what we plan to do in the very next sprint. And you basically get 45 of these every 3 weeks that you can keep up with the rest of the team. How do we do our planning? We used to do an 18th month strategy, and now we've reduced that to a 12-month strategy. The strategy is the LT leadership going to conferences like this, reading all the rags, speaking to all of our customers, and saying 12 months from now, where do we believe our product needs to be? If we only do 60% of that 12 months in the future, that's still a success because the world changes, right? You can't just go ahead and say, we're going to do this for the next 12 months and do it blindly, even if it's no longer relevant anymore. Inspect and adapt, and that's what we're constantly trying to do. We then take that 12-month strategy and we break it down into 2 6-month seasons. Those seasons used to align with Build as one conference and Connect as the other conference, around May timeframe and around November timeframe, basically 6 months apart. And what we would do is we would make huge announcements there. So what we do is we break down our strategy into what do we want to announce at Connect and what do we want to announce at Build. And then our teams would strive towards that. We're hoping to get about 80% of that 6-month thing done. And then what we do is we start sprinting every 3 sprints. We have a meeting called a planning meeting. So we sprint 3 weeks, and then every 3 of those, related teams come together and kind of have a scrum of scrums. It was really cool. I got to sit in on one of these. Aaron Bjork runs all of work item tracking. So the Kanban board, the backlogs, the task integration, all that stuff is owned by Aaron. He has like 5 or 6 different feature teams that work on those features. And every 3 sprints, he has a meeting. And I got to call in on one of those one time. It was really cool. So everyone's in there. They're eating pizza. One of the engineers starts talking and says, okay, this is what my team is planning to do. We're going to create this cool little widget. It's going to allow our customers to do X, Y, and Z. And another engineer said, hey, hold on. What does the widget do again? It's interesting. One of my engineers just wrote a widget that looks just like that. Why don't you use their widget instead? Without that meeting, we would have 2 widgets doing the exact same thing inside of our product. But allowing the teams to come together and share what they're doing allows them to make sure they can reuse the code. The biggest problem with code reuse is not knowing the code is even out there. If you don't do code reviews, if you don't have a way to communicate that, then you're going to end up with a lot of duplicated code. And this is a great meeting to make sure that you know that you're not duplicating people's efforts, and you're also aligned on what our vision is as a feature team amongst other feature teams. Very powerful. We have something we call aligned autonomy, which means our teams have autonomy to work on everything that's highlighted now, but the leadership owns what we're going to deliver at those big milestones and the actual strategy itself. Said a different way, if I were to slice this differently, it looks like this. At the top is where all of our ownership from our leadership is, and then at the bottom is what's actually aligned by our developers themselves. They are the ones who determine if they want to treat their 3-week sprint as 3 one-week sprints or not. But the way that we keep them aligned is in 3 weeks we're shipping. If you want to do Kanban instead of Scrum, knock yourself out. If you want to do paired programming or test-driven development, go for it. But you better be ready in 3 weeks to ship, because that's when we ship. So you have autonomy to run your team the way that you want to, but you're aligned by the fact that you better be ready to ship in 3 weeks, right? So we call it aligned autonomy. It's a very powerful concept. Our program manager basically plays the role of our product owner. They define what and why. They talk to our customers, go to conferences, use the user voice, do the research, and they basically control the product backlog. And then we have our engineers who basically say, this is how we're going to develop it, and they're also responsible for the quality of the product itself. A lot of architecture looks like this. You have a UI layer, API layer, and a data layer. The problem with architectures like this is when teams think that they own one layer or the other. I'm sure a lot of you work in a scenario like that right now. One team owns the database, one team owns the UI, and one team owns the API. There's a lot of coordination that has to happen. There's a lot of dependencies that have to be resolved. It can be very problematic at times. And it's a lot better if you want to strive for vertical. I own this entire feature. I own the UI, I own the API, and I own the database schema. I have a cross-functional team that has the expertise necessary to own the entire feature. So now all of a sudden, a lot of those barriers are automatically broken down. And you stop thinking about your application in layers. If you're working on an application and you're at sprint 0, I remember where teams was like, man, this first sprint's going to be tough because what are we supposed to show? We got to go figure out the entire ER diagram for our database. Like, no, you don't. Yeah, we do, Donovan. I've been a database designer for years. I got to go figure out every possible key, every column, every freaking foreign, everything has to be figured out before we write a single line of code. Like, what are we supposed to show our stakeholders at the end of the sprint? An ER diagram? They don't have no idea what that is. Like, that does not add value to me. Like, nope, Donovan, we got to do that. Like, this is ridiculous. We don't have to do that. And they just kept saying they do. Like, all right, fine. This is what I'm going to do. I'm going to make a deal with you. I'm going to give you 3 months to go do the entire database, like you say that you have to. You got to make me one promise. It's like, what's that? Don't change it. You can never change it. Donovan, that's ridiculous. Like, then why the hell am I giving you 3 months to do it then? Right? If you're going to have to change it anyway, just give me what I need for us to have a vertical slice. If all I need is a login page, how many database tables do I need? 1. How many columns do I need? Username and password. Go get me that right now. Right? So I can actually go show my customers that we can have a login page, an actual website completely deployed into production that only lets you log in but does something. That gives me a tracer bullet. Right? That allows me to know that I can take data from the UI down to the database and back again. I know my architecture is right. I know my infrastructure is right. But you're telling me that I should give you 3 months to go do a database table that you're going to change anyway. Just call bullshit on people. That's basically like short, long story short, right? Like, don't let someone tell you that nonsense when you know it's nonsense, right? And that's not the way the world works today. What we're going to do is we're going to add one table, 2 columns. And the next sprint, we're going to add some more columns and maybe some more tables. And next sprint, we're going to keep on doing that. Because we're going to move your database the same way we move every other portion of our application. And that's going to give you the agility that you need. Another thing that we had to change drastically was the way that we do quality. One of the things that we used to have is code complete, code freeze. All the developers know what code freeze is. We've all had one of those. That's basically a polite way of saying, please stop typing. Right? Because if you keep typing, you're going to keep adding bugs, and we have to go count the bugs you've already added. So please go entertain yourself, go have a pizza party, pat yourself on the back, call it a milestone, whatever you do, just stop freaking typing. Right? And then what do? We give the code to the QA team, who is furious now because this is the first time they've ever seen this code. They weren't involved in the planning whatsoever, and now they have to go test this black box. And they do their best, and all they do is find bug after bug after bug, many of which aren't even bugs, but because they don't know how it's supposed to work. And it didn't work the way that they thought it was supposed to work, they logged that as a bug as well, right? Because they weren't involved in the process. So now what we have is this huge mountain of technical debt, and we have to go do a bug bash, and whatever quality is in the product at the time it's supposed to ship is what we ship. Miserable way of doing software. It looks a lot like this. How am I supposed to know if I'm ready to ship if the amount of technical debt that I have is a variable until we go back and count all the bugs? We should be counting those bugs as we go. But again, that changes your whole paradigm. You can't be bolting quality on. You have to be designing quality in so you can be counting how many bugs you have in real time and determine if you need to go pay down that technical debt. Okay? This is not easy stuff. And I'm going to be one more thing I want to say real quick. I hope you were not hoping that I was going to get up on stage and say, these are the tools that we put in place at Microsoft, and now we have DevOps. That's not how it works, right? We had to re-architect a lot of what we do at Microsoft so that we could move it at the speed in which we wanted to move. Do not think it's just getting tools in place. It's about changing your mindset and making sure that your application is designed to be deployed at the speed in which you want to deploy it. And putting quality into the product itself is a key part of that, okay? Buck Hodges is our director of engineering. He got sick of this stuff. He said, I don't want this anymore. What I want is something that looks more like this, to where we can actually measure constantly our technical debt, pay down that technical debt. It's like interest on your credit card. The longer you wait, the more painful it is to pay off. That unit test you promised to write yesterday, but you didn't, and you promise you're going to write it tomorrow, but you don't. Next thing you know, that's 10, 15, 20, 30 unit tests you've never written, and bugs just piling up on top of us. So what Buck Hodges said is, I want to be able to know that we're a week away from shipping. The way that he figured that out is that he calculated that on average, our teams clear 1 bug per engineer per week. So if I want to be 1 week away from shipping, how many bugs per engineer can I have? 5, right? So if I know I don't have any more than 5 bugs per engineer, I can say, on Monday, I want to ship on Friday. Everyone stops adding features, starts paying down that technical debt. We should ship on Friday. Makes perfect sense, right? So what we had to do is calculate what we call a bug cap or a bug bar. And that is literally 5 times the number of engineers on your team. Well, how many bugs do we have? We know that because we've been writing unit tests the entire time. If you have more than 5 unit tests that are failing, you got to stop what you're doing and go pay down that technical debt, right? That's how we're able to keep track of it. Remember I said measure everything that you do, like the 2 people that didn't move? We do that. This is us measuring the bug bar on our teams inside of Azure DevOps. Let me zoom in a little bit for you. This column here is what the average bug bar was throughout that previous sprint. If it's above 5, that's a problem. If it's below 5, that's great. If it's below 1, that's suspicious. I'm not sure that team was working that sprint, but nevertheless. Now, one of the things that's most critically important about a chart like this one, like for example, the 7.68, you cannot punish the team for these numbers. And I'm going to say that again. When you start measuring stuff like this, you cannot punish the team for these numbers. Why? Because engineers are very smart people. And if I get in trouble if that's above 5, it'll never be above 5 again. Even if it's supposed to be above 5, you will never see a 5 in that column ever again because I will game the system because I'm smart. However, if you use this to inspect and adapt, you're going to succeed. Because what we need to do for this team is simply go and talk to them. What happened, right? Was it you bad estimating? Did you have technology you'd never worked with before? Do we need to get you more capacity? Do we need to get you more training? How can we inspect this number and adapt our process so that you succeed? Because as a manager at Microsoft, if these numbers are on my team, it's my failure, not my team's failure. Right? I need to take responsibility for that. I did not enable them to stay below that, or I did not educate them on how important it was to stay below that, so they did not take this number seriously. Right? This is not something that you punish your team for, because if you do, they're going to game the system. This is how we measure the quality of the product that we're shipping. But there's another way that we measure it as well. This is what we call our engineering scorecard. Our engineering scorecard is measuring our live site. So when you're running a product that is in production 24 hours a day, 7 days a week, you can't take it offline to fix it. These are live site issues that you have to go back in and fix. And what we do is we measure this as well. And again, if it's red, we do not fire anyone. We don't threaten anyone. We basically have a communication on how we can turn the red ones yellow and the yellow ones green. Constantly inspect and adapt. And what we're doing here is we're measuring how long did it take us to even detect there was a problem. Was that problem detected by our telemetry, or did we get an email from a customer, which is the worst possible way to find out that you have a problem? The best case is that we know that there's a problem before you do, and we fix it before you even feel the pain of it. And we need to have the telemetry that does that. We collect about 7 terabytes of telemetry a day on this product. And we've written a lot of cool tools, and a lot of them that we've now made public so that we can comb through that data and make sense of it. And what we do, again, is figure out how long it took us. Did we have the right telemetry? How long did it take us to mitigate, right? You cannot mitigate by simply turning the server off and back on again, right? The way that we mitigate a lot of our problems is through something called feature flags. Is everyone familiar with feature flags? Heard of feature flags? Great technology, great pattern. It does not come for free, right? I always tell people they are not unicorns that crap Skittles. They're not all fun and games, right? There's technical debt when you actually add feature flags, but the value that you get out of them is far greater. Because when we mitigate one of these problems here, we can literally just turn the flag off. We don't need the guy with the jack behind the guy with the jack, right? What we simply do is like, all right, we've just deployed a new feature. That feature's not working correctly. Let's just turn that feature off. All the same zeros and ones are on the server, but now all of a sudden all of our customers are being successful again. By doing it that way as well, we don't corrupt the crime scene. If you just reboot the server when you have a memory leak, what have you guaranteed? That you still have a memory leak. And unless you know the perfect timing, you're going to have another memory leak. Unless you can just put a timer that says every 4 hours, let's just go reboot the server, which is still not a sustainable way of doing running a service. So what we do is we mitigate the problem. We then go back and do what we call a root cause analysis. Root cause analysis is where we find out the root cause of that problem so that we can go back in and prevent that from ever happening to our customers again. When we have one of these live site instances, we're very transparent about it. The most recent one was when we had a data center struck by lightning in San Antonio. There's an enormous write-up of exactly when the lightning struck, what parts of the data center it took out, and why some of our services were down, and what we're going to do to make sure that that never happens to our customers again. And that we put that in our product backlog as features that you have to go back and implement now above any new features to make sure that if we have another data center struck by lightning that takes out the air conditioners and starts to melt servers, that we are going to have our customers up and running with no interruptions to their work. That's all captured on this chart here for us. Right? And again, this is owned by operations and developers. There is no finger pointing anymore because they're both incentivized to deliver value to our end users. Otherwise, this would just be on the engineering and the other one would just be on the developers, but it's not. As long as you have the same vision, you start to work together and it becomes really, really easy. So let's start to wrap up just a little bit here. Transforming an engineering organization was really hard for us because we had to go from a multi-year cadence to what we call internally as cloud cadence. That is moving as fast as you possibly can. 3 weeks is just where we are today. It's not where we want to be. We want to be continuously shipping features all the time. And I say we ship every 3 weeks, which is a little bit of a misnomer. We actually ship twice a day, but the twice a day shipments are just bug fixes, performance improvements, hot fixes, things like that. Every 3 weeks is when we get up with a big announcement and we basically write up this big report that says these are all the new features you now have access to that we shipped in the every 3 week sprint. So we actually have figured out how to ship every day, but we want to make sure that we're cognizant of the ability for you to even keep up with the changes that we're making. And we have a better vehicle of educating our customers of what's coming. We're going to be able to move even faster as well. This was a big one for us, right? Moving from dev and QA to just an engineer. There's a couple transitions that happened here. We used to have manual testers, and on our team, we no longer have manual testers because we are our own manual tester because we are the first people to use the product. So again, the 4 teams I showed you, the 4 areas in the world with the 45 teams, those teams actually use an instance of Azure DevOps to develop Azure DevOps. And whenever we ship out new features, we are the first team to get it. So we never push it out to our customers before we've used it for a minimum of 48 hours. So here it is, 3 weeks have come up, it's time to ship all these new features, they go into ring 0. And we come in on Monday morning and we have to use that product for 48 hours. And if it cannot survive 48 hours with us, we do not go any further in our deployment and our customers never see it. We go back in, we make any fixes that are necessary, we push it back out to ring 0, and we try to get our job done again. We're monitoring telemetry, we're monitoring bugs, we're monitoring any weird anomalies that might happen while the software is running. And if it survives 48 hours with the actual Azure DevOps team, we then give it to what we call our friendlies. These are people who have asked for early bits, there are MVPs, there are friendlies, right? They know that they're getting early bits, but what's cool about them is that they use features of the product that we don't use. We are entirely Git inside of the Azure DevOps team. So we aren't testing TFVC anymore. But a lot of our early people are, because they have customers who are still using it, they have projects of their own that are still using it, so they're able to use features that we don't use every day, and they are our manual testers, and they know that. Before Brian Harry left, I remember asking him, so we test in production? He says, unapologetically, we test in production, because there's nothing like production. There's never a QA environment that you're going to be able to build that's going to act as crazy as production acts. Right? And acts as crazy as our customers act. Not maliciously, but they just do things you never imagined that they're going to do that causes horrible things to happen in your software. So that's where we test. It's been very important for us to join those two together. Now we used to have, so when we got rid of our manual testers because we were our own manual testers, the next thing was to get rid of our automation engineers. We used to have 27,000 UI tests, 27,000 of them at our high point. How many times did we run all 27,000 UI tests and they all passed? How many times? 0. 27,000 UI tests that have never, ever passed all at once. So why are you running them? Because when they fail as an engineer, I'm like, yeah, some of them always fail. I don't know if it's because of what I just added or the ones that failed yesterday, right? So I'm not even listening to the signal. So you're paying all this money to build them, to maintain them, and they're really slow to run, and no one is paying attention to the signal. So what we had to do was change our mindset, re-architect our application so that we could use unit tests instead. So now we run 84,000 unit tests in under 8 minutes against our entire code base, getting higher code quality, getting higher code coverage, and if any single one of them fails, everyone stops what they're doing, they go figure out why that thing failed, because they're never supposed to fail. Right? So we had to go from mostly manual and mostly functional to mostly unit, which is incredible. Another thing you have to do is make sure that your unit tests are fast and reliable. If you've ever had a quote-unquote unit test start failing out of nowhere and then just start passing when you didn't change the code, first of all, that's not a unit test because you haven't isolated all the external dependencies because it was an external dependency that was not the shape or did not meet all the assumptions that you were expecting it to be that caused it to fail and then it automatically started passing again. So running your test over and over again and making sure they're reliable and fast was key for us because you can't do 600 pull requests if it takes hours to run a pull request, right? And we do 600 of them a day. Another thing that was really important for us is that we had to have a zero downtime mindset. I bet the application that you have today, especially even if it runs in the cloud, is not designed to be updated while it's running without it ever having to be taken down. Right? Most apps aren't. Most apps are very optimistic. You copy me, I run until you stop me, and then you copy a new version, and then I run, and everything's great. But during that copy, there's downtime. We can't have that. There are people on our service 24 hours a day, 7 days a week. There's no time appropriate for us to take it down so that we can upgrade it. So we had to re-architect our system such that it could be upgraded while it was running and no one would realize that it was happening. If you've ever had something that used to take 3 milliseconds take a second, that was your indication that we had just upgraded your system. You hit it at the exact time that we were upgrading, but you didn't get an error. You didn't have to retry anything. It just took a little longer than last time. But we had to design that into the product itself. Another way that we had to change our architecture so that we could have zero downtime is the way that we deploy our microservices. Our microservices, for example, are smart enough to be able to talk to someone who's not at the version that they want them to be at yet. If I have a dependency on this gentleman has a dependency on this gentleman, and you on him, which one do we have to deploy first? The last guy. Right? You have to go, be deployed, and be safe. Then you can go, then I can go. What a nightmare that is when you have 30 microservices. And now you got to orchestrate which order they get deployed in. The perfect world is they can get deployed in any order that they want. And our microservices can. Because our microservices basically ask, what version are you at? Damn, I really wish you were at 2, but you're still at 1. Okay, I know what 1 looks like. Go ahead and give me the 1 data so I can keep doing my job. And then the next time I have a session with you, I'm going to ask you, what 1 are you at? You're at 2, perfect. That's exactly what I want. Let's go ahead and start using 2 together, and we're going to start doing some cool stuff. But that means I can be deployed even before they're deployed. So now all of a sudden my deployment's really, really easy. But your microservices just don't do that out of the box. Right? Microservices have to be designed to be able to negotiate at runtime what language and what communication we're going to talk to each other, and we did that as well. Another thing that was really important for us was to make sure that it was a fully automated deployment. First few times we did this, it was not, and I'm sure many of you live in this world as well. We used to run a lot of PowerShell scripts as part of our deployment, a lot of PowerShell commands. Have you ever copied a PowerShell command from a Word document and tried to paste it into PowerShell? What ends up happening? What ends up happening is that those quotes aren't quotes anymore. Right? There's this weird special quote that just wreaks havoc on everything, and you're Control-C-ing your ass off hoping that the command didn't run, right? Because it didn't copy and paste correctly. It's a really dangerous way of doing that. So what we had to realize is that we can't have Word documents with all these weird one-off steps. We have to have a completely automated process to be able to deploy it, and we did that as well. You also have to have a joint ownership between engineering and ops. That's that last chart I showed you, where we were tracking LSIs, tracking time to mitigate. We own that together. There is no pointing fingers. Either our customer is getting value or it's not. Decoupling our services is how we got those clear contracts, which allows us to deploy them in any order that we want. And then finally, feature flags. Feature flags are an extremely powerful concept, but please realize that they do not come for free. Right? There is technical debt. At some point, you got to go and clean them up. Right? When you have them, it increases your cyclomatic complexity, so the code becomes harder to read and harder to maintain. But when you have a live site incident and all you have to do is turn a feature off to get your entire system stable again, it's worth its weight in gold. Right? So there's reasons that we use it. Not only do we do that for exposure control, but we also do it for big announcements. Like I said, we have build and we have connect. These two big giant events where we want to deploy all these cool new features to you. Well, we can't all deploy the features the day before. They have to be tested. And what we're able to do with feature flags is actually put them out there weeks, months in advance and test them, because we don't have to turn a feature flag on for everybody or not. I can turn a feature flag on just for the first row. People that I trust, people that I want to get feedback from. People that know that it's going to be flaky, and then give us that feedback, and we're going to keep on revving on that particular feature. And then once it's able or stable, we're going to then turn it on for everyone in the room, which is what we do at the big announcements. So it allows you to go ahead and work in these small batches of work with these feature flags. Another thing, if you're new to Agile and you have a feature that takes more than one sprint to do, what do normal people do? They cut a branch, and that branch lives for the entire life of that feature, 2, 3, 4 sprints. And then when you try to merge back into master, boom! Big merge bomb, right? There have been so many changes from master, from your branch, that the merge itself takes longer than it did to implement the feature itself, right? It's called a merge bomb. It happens all the time. But the reason why is because the feature's not done. And once you merge it into master, that's shipped. Merging into master for many people is releasing and deployment at the same time. What we're able to do with feature flags is actually separate releasing software from deployment of software. Just because the software is deployed does not mean it's released to our customers. If the flag is off, it's not actually released. It might be deployed, which is drastically different, right? So using feature flags allows you to separate the difference between releasing software and deploying software. And we do that quite a bit so that we can actually control the flag, let people see it, make sure the feature is good before we turn it on for everyone else. And we also implemented it where you can turn on feature flags for yourself. For example, if you ever see one of us do a demo and we have features that you don't have, just go into Azure DevOps, click on your face, and there's going to be a drop down that says preview features. Those preview features are toggles that you can actually turn on yourself. And those are feature flags that you're saying, I would like to play with this feature right now. And we get a lot of cool telemetry from that. Because if you turn that feature back off immediately, what does that tell us? You didn't like it, right? So we're monitoring not only the feature flags that we turn on, but the feature flags that you turn on, because if you turn them back off again, we know that that feature is no good. So again, feature flags, brilliant. There is technical debt, but there's no way in the world we go back without using feature flags. So how do you get a hold of me and my team if you need our help? This is my team. As a matter of fact, I think she was just here yesterday. That's Jessica Dean. She is open source, Kubernetes, Docker, everything. She has bailed me out. I can't tell you how many times I completely corrupted our Kubernetes cluster. And thank God she was on my team, because I just sent out a, holy crap, please help me. She's like, hold on, what did you do this time? And she would explain it to me. So I'm like, okay, I will not make that mistake again. But I broke it a different way next time, right? So I told you I wasn't going to break it the same way twice, and then she fixed it again, so she's amazing. If you need help with Chef or you're a Windows operations person, that is Steve Moraski. I got him from Chef, so if you need help with Chef, that's exactly where you come from. You need help with PowerShell, that is your guy. I'm Donovan Brown in the middle. I am a 20-year dev. I've been doing DevOps for a long, long time. I worked with several people that are in the room now when we worked at a company called Notion Solutions together as process consultants, exactly. So this is basically what I do. I write software every day. Even when I retire, it's just going to be what I do. Damian Brady, he used to work at Octopus Deploy, so if you use Octopus Deploy, he can help you with that as well. Great DevOps mind. And then Abel Wang, hands down the best programmer I've ever met. Just got out of surgery, and the first thing he did is wrote hello world just to make sure that the anesthesia had worn off, right? That's that guy. So if you want to write good software, that's the dude you freaking call. If you want to get a hold of my team, you can use that hashtag right there on Twitter. If you use that hashtag, all 5 of us will come and read it. And what I found out recently is there's a lot of other people inside of Microsoft monitoring that hashtag. So when you actually use it, you're getting inside of Microsoft, and we're all going to go read your tweet for you. Using that hashtag is sort of like using a bat signal. So when you, literally, all 5 of us will go and read it, and I've added Aaron Bjork, Buck Hodges, you name it, Gopi. I've added all these people inside of Microsoft. Like, hey, I don't know the answer to this question, but this person is actually the PM that owns that, right? So you can talk directly to them, corner them for dates, all kinds of cool stuff. Using Twitter is an amazing way to get feedback from us because it's public, right? I mean, shame us if you have to. I mean, I'm telling you what to do. I've written blog posts that are not very flattering because I knew it would get a motivation out of people that I needed to go have that motivation. I've actually had a person tweet at me, and 3 hours later I had a production fix in Azure DevOps. 3 hours. from a tweet coming to me to us having a fix for that person. So use this wisely. But do not test it. Please don't go and say, I wonder if this is going to work, hashtag the league, right? It works, and we're going to read it, and we're not going to be laughing like you are, right? You're going to be giggling, and we're going to put you on the list. Like, don't answer that person anymore. All right, so let's some more last-minute resources here. Azure Friday is a fantastic show. Channel 9 is where we curate a lot of this stuff. We're moving up most of it to YouTube, but you can still go to Channel 9. Azure Friday is Scott Hanselman's show. I don't want anyone to think that it's my show. It is definitely Scott Hanselman's show, but when he can't make it to Seattle, I usually fly up there and do a lot of shows as the host as well, especially if they have to be DevOps related. Visual Studio Toolbox is a great way to learn what's coming out with Azure DevOps and anything else Visual Studio related. DevOps Interviews is where you can learn more about everything that I've just said on this stage. You want to learn how we do planning? There's a show with Aaron Bjork. You want to learn how we went from 27,000 automated tests to 80,000 unit tests? There's a show with Manil Shah. That's Manil right there. Any show that has this gentleman in it, and he's been on the show 3 times, watch that show. He tells us how we do safe deployment. He talks about how we do quality. And then there's another one with Aaron Bjork. Aaron Bjork has also been on there 3 times, and he'll be on there for a record-setting 4th time when I go back in 2 weeks, because we're going to talk about how we do planning. He talks about how we do consistency. When you have 45 teams working on the same product, how in the world do you keep the UI consistent? It's a challenge. Aaron tells you how we do that. You have 45 feature teams all working on a UI. How do you not have Vue and Angular and like every other type of UI framework? Oh, by the way, we had them all at one point, right? We literally had every JavaScript framework was inside the UI at some point or another, and you have to figure out ways to keep that consistent, and Aaron tells us how we do that as well. DevOps Lab is a little bit of a different show. We actually sit down with individuals and talk to how we solve a particular problem, which is really good too. So depending on whatever flavor or whatever altitude of a conversation you want to have, we probably have a show that will actually help you talk to it at that level. Again, I'm at Donovan Brown on Twitter. It is the #1 way to get a hold of me. Don't ask for my email. Do not give me your business card. It's simply not going to happen. If you need to get a hold of me, you tweet at me, and I will get back to you within 24 hours, right? And if we need to have a longer conversation, follow me. I'll DM you, and we can go to town and get you solved, right? This is the #1 way to get a hold of me. My entire team is on Twitter, so I can add anyone that you saw on that last slide. You can get to my entire team and many others inside of Microsoft with that hashtag. I also blog at donovanbrown.com. Anything that I've had to struggled with, if it takes me more than 5 minutes to figure it out, I've probably blogged about it because I knew I was going to have this same problem again. And it's funny how many times you find your own blog and you like this weird deja vu, like, I know I fixed this before, damn it. And you start searching for it, and lo and behold, yep, I sure did. There's the blog post that I remembered that I'd already fixed this before. So please use that to your advantage as well. I have about 3 minutes left. I am more than happy to answer some questions before we get to lunch because I know they're setting up lunch. So that's all I have for you today, but please ask me any questions that you have, and thanks for having me.